In this final example, we'll consider basically a pellet hitting a disc. A large pellet strikes a solid disc as shown in the figure below. The pellet was traveling at 1 meter per second and has a mass of 1 kilogram. The disc has a mass of 10 kilograms and a radius of 1 meter. Right? If the disc is not initially rotating, what is the final angular velocity after the hit? Alright, well, this is very nice. We actually have the initial system here, and the final system is just going to be our disk again, with now this thing stuck on it, and the entire thing rotate with some omega. Alright, fine. Alright, so let's write down what the initial conditions are. So it's going to be L1, let's call this 1, call this 2 initial, plus L2 initial is equal to, basically, this is just L final. Alright, I won't break it into 1 and 2, and you'll see why in a second. Alright, let's do the final state first. This actually turns out to be a little easier. What this turns out just to be, because everything's rotating with some omega, basically I of the two things together times omega final, which is just going to be equal to I1 plus final. Well, we'll just write down what it is. This is just going to be basically the mass of the pellet, so mass 1 times basically r squared plus 1/2 I2, which is going to be 1/2 m2 r squared. Right? Okay, omega final, right? Which is equal to, let's plug in the numbers first. This is going to be 1 kilogram 1 meter squared plus basically 1/2 times 10 times 1 squared again. Whoops. I'll move over slightly. 1 squared again. Omega f. So this is ultimately equal to 1 plus 5, right, is 6 omega f. Alright, so that's fine. Now let's look at this part here, okay? Now the tricky part here is to realize that L1 is going to be slightly different than what you expected before, right? So there are two ways to approach this problem, okay? One way, and this is by far the simplest way, is to find how far off from the rotation axis perpendicular is the velocity. And that would have to be 0.4 meters, right? That's probably the easiest way. The second way is actually figure out what the angle is, basically, of r cross f. Alright? In either case, you end up with the same thing. So we'll just basically do the simplest way first, which is basically picking it off based on what's called the impact parameter, which in this case is by 0.4. Right? It's basically the distance from the rotation axis, that the shortest distance from rotation axis that the velocity vector would make if it came basically anywhere. Right? So let's just do this. 0.4. Okay. So the initial angular momentum is going to be basically m v b, where b is the impact parameter, and 1v1 initial times b, plus basically L2, which is going to be I2, that's the side of this, times omega 2 initial. But omega 2 initial was initially at rest, so this is going to be 0. So we just have mvb, right, where b is equal to 0.4 meters. So what's m1? m1 is 1 kilogram, v is 1 meter per second, and b is 0.4. Okay, so this is equal to 0.4, which is equal to 6 omega f. So now we have omega f is equal to 0.4 over 6, which is, break out the trusty calculator, 0.4 divided by 6 is equal to, mark of the beast, 0.0067. Okay, well, hope that was, of course, let's remind ourselves what the units are, radians per second. All right, well, I hope that was useful. I'm certain this will be useful to you. Okay.